Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on gravitational field from March 2022, Paper 4, Variant 2. In this question, we will discuss how to calculate mass of a planet. We will also discuss how to sketch gravitational field around any mass. At the end of this lesson, we will also discuss how to calculate orbital speed of moon. For question number 1, part A, it is given to us the point P in figure 1.1 represents a point mass. On figure 1.1, we need to draw lines to represent the gravitational field around P. This dot P is representing point mass. In order to draw lines around point mass, we need to understand gravitational force is an attractive force. So the lines has to be pointing towards this point mass. So this is how you can draw the lines of gravitational field. So lines has to be pointing towards this point P. So this is how we can draw the lines. You have to draw at least 4 lines, but you can draw more than 4 as well. So we can draw 8 lines. So this is how we can draw the gravitational field around the unit mass. Now the question is that why these lines are pointing towards unit mass. One reason you can say gravitational force is always attractive. The second way to explain this one is if we place a unit mass, let's say at this point. So this one is over unit mass and this is the point mass. So the force on this unit mass, it is towards point mass. Means it will experience attractive force. If we place unit mass here, this will also experience attractive force. Means direction of force on this unit mass is towards the point mass, So that's the reason we have to draw arrows pointing towards point mass. Or simply you can say gravitational force is always attractive force. That's the reason these arrows are directed towards point mass. This question has 2 marks. If you have drawn the 4 lines and they are pointing towards point mass, you will get 2 marks. For part B, it is given to us a moon is in circular orbit around a planet. Explain why the path of the moon is circular. First, imagine that we have a circular orbit and at the center of this circular orbit planet is located. So the planet is located at the center of this orbit and the moon is orbiting around this planet. So we can use letter capital M for the moon. Imagine that the moon is moving in counterclockwise direction. So we need to understand as the moon is moving in a circle, so there must be a centripetal force. Because this one is doing circular motion, so there must be a centripetal force. Now we need to understand centripetal force is not a force by itself. So centripetal force has to be provided by another force. Centripetal force in this case is provided by gravitational force. So we can simply write down. In this case, centripetal force is provided by gravitational force. Means force on this moon by the planet. So this one is the gravitational force. So this is our 1 point we can write down. Now we need to understand as this moon is moving in a circle, in a perfect circle. So the angle between this force and velocity of the moon, it has to be 90 degrees. So we can say the angle between gravitational force and the velocity of the moon is 90 degrees. Or simply we can say the centripetal force is perpendicular to velocity, or we can say gravitational force is perpendicular to velocity of the moon. So this can be the second point. And the third point we need to understand as this moon is moving in the circular orbit, means it is moving in a perfect circle. So the magnitude of gravitational force means the magnitude of centripetal force, it has to be constant. So we can say gravitational force acting on the moon is constant. So we can say gravitational force is constant. So these 3 points we have to write down for the answer of this question. Now let me show you how you can write down a proper answer. So this is how you can write down your answer. First thing, you can say gravitational force provides the centripetal force. You cannot say gravitational force is equal to centripetal force. Gravitational force provides the centripetal force. So you have to say provides, not equal to. But the centripetal force is perpendicular to velocity of the moon and magnitude of gravitational force is constant. So these 3 points you can mention. If you write down, you will get 2 marks. For part C1, we need to show that mass capital M of the planet is given by this expression. Means mass of the planet is equal to gradient over universal gravitational constant. First of all, let's imagine that mass of the moon, small m, is representing mass of the moon. So simply we can write down here, small m is representing mass of the moon. In this question, we have already discussed that gravitational force provides the centripetal force. So now we can say Fg, we can equate this one with Fc. Fg, gravitational force, this is equal to capital G, capital M, small m, means mass of the planet times mass of the moon divided by the distance between the centers of moon and planet. And this is equal to centripetal force, mr omega square. Now in this case, you can see we have m on both sides, so we can cancel this m with this m. So simply we can cancel mass of the moon on both sides. We have to show that capital M is equal to gradient over G. Now we can rearrange this one, so we can write down mass of the planet. This is equal to r cube times omega square divided by G. Now if you look at the gradient of this, so we can write down here gradient of this graph is equal to r cube divided by 1 over omega square. If we simplify this one, we can write down gradient is equal to r cube times omega square. So if we look at this expression, this is equal to gradient. So simply we can replace this one with gradient. That's all what question is asking us to find out. So we can say mass of the planet is equal to gradient divided by universal gravitational constant. So if we have done this one, you will get 2 marks. First mark you get, that is M mark, if you have written this expression. Means you have equated gravitational force and centripetal force. Means if you have written the formula for gravitational force and centripetal force. And the second mark is the answer mark. If you have got right answer, you will get the second mark. For the second part, we need to use figure 1.2 and the expression in C1 to show that mass capital M of the planet is 1.0 times 10 to 26 kgs. This is figure 1.2. So here we have figure 1.2. We have already found expression for mass of the planet, and we have found that mass of the planet is equal to gradient of figure 1.2 divided by capital G. Capital G is a constant, so we can find the value of capital G from given values of constants. So we don't need to worry about capital G because its value is given. What we need to find out is we need to figure out the gradient. So first of all, let's try to find out gradient. In order to find gradient of this line, we will take 2 points. So we will take 1 point here and we will take another point here. So this point is at origin. So in this case, simply we have value of r cube, that is 4.1. So we can say this is 4.1 minus 0 times 10 to 23. This is very important, this multiple. And if you look at value of 1 omega square, we have 6.6 0 minus 0, and this is also multiplied with 10 to 7. So this is value of gradient. As we can simplify, we can write down this is 4.1 times 10 to 23 divided by 6.0 times 10 to 7. Now we have to plug in this value for gradient. So simply we can say gradient is equal to 4.1 times 10 to 23 divided by 6.0 times 10 to 7. So this is value of gradient. And we have to multiply this one with 1 over g. So we can write down value of g here. G is equal to 6.67 times 10 to negative 11 Newton meter square per kilogram square. Now we need to solve this one. If we solve this, our final answer up to 2SF will be equal to 1.0 times 10 to 26 kgs. So this is our final answer. And this question has only 1 mark. If we have got the right answer, we will get this 1 mark. For the last part, we need to determine the speed of a moon in orbit. It simply means that we need to determine the orbital speed of the moon. So we can write down, we need to calculate orbital speed of the moon. Means in this case, we have planet that is at the center of the orbit, and we have the moon, and the mass of the moon is small m. We need to find out what is speed of the moon. We need to find out what is the speed of the moon in this orbit. So that V is called orbital speed. But orbital radius is given to us. Means the distance from the center of the planet to center of the moon is given. And this one is orbital radius. Let's say this is R. In order to answer this question, again we have to start from gravitational force provides the centripetal force. Again we have to write down gravitational force G capital M small m over R square. And this is equal to mv squared. Now we will be using mv squared because we need to find the speed of the moon. So we have to find speed of the moon, so we will use v instead of omega. Now in this case, again we can cancel mass of the moon, so we can cancel mass of the moon, and this 1 r we can cancel with this. So we left with g capital M over r, and this is equal to v squared. So we can simplify this one. We can write down v is equal to g capital M over r root of this. G is a constant, and the value of G is 6.67 times 10 to negative 11. And mass of the planet we have just found in second part, that was equal to 1.0 times 10 to 26 kgs, and we need to divide this one by orbital radius. Orbital radius is 1.2 times 10 to 8 meters, and we need to take root of this. If you take root of this, we will get our final answer. Final answer will be equal to 7,500 meters per second up to 2SF, and this is our final answer. This question has 3 marks. You will get the first C mark if you have equated these two forces. You will get first C mark, and the second C mark you will get if you have plugged in values of capital G, capital M, and orbital radius. Then the last mark is the answer mark. If you have got the right answer, you will get the third mark. Our answer is up to 2SF because the least number of SF in given data we have is 2SF. That's the reason our final answer also has 2SF.